Hi, welcome to the Retirement Railroad Matinee Modeling Tip of the Day. I'm Steve, and today we're going to look at something. I'm going to install something that I've wanted for well over 6 months. I was watching Chadwick Model Railway, Charlie Bishop, and he had an alpha meter from DCC Concepts, which is a English or UK company, and I've been watching and wanting one, but I didn't want to pay for shipping from the UK, and I couldn't find a place here in the US for a long time. And one of my fellow model railroaders, Heath from Humanity Junction, had gotten one. All right, and he got it from Iron Planet Hobbies. And Heath has a discount code at Iron Planet Hobbies. So I went and I looked there, and what was like 79 pounds English plus shipping to the US. Iron Planet Hobbies, and just to put it in perspective, that's about $125 to $150 with the exchange rate, which was beyond what I was willing to pay. But Iron Planet Hobbies had it for like, I want to say $59, $64, something like that. And then with Heath's discount code, I think I got it for $54, and it was free shipping. Couldn't beat that deal. So I ordered one, and it arrived yesterday. Now you may be asking, what is an alpha meter? Okay, from DCC Concepts. What it is, it measures voltage and amperage on the track, okay, or we're in line for wherever you install it. Okay, and why is that important? Why don't you just use a regular voltmeter? Well, a regular voltmeter doesn't work typically it does not work on DCC. Now, in the old days, straight DC system, your throttles or power packs would have a voltage voltmeter built into them, or could have. Not all of them did, but could have. And you could look and see what your track voltage was. You could see how much power the locomotives were drawing, and that's a nice feature in that if you've got a motor going bad, and it's drawing a whole lot of voltage, you can catch it before it causes a problem. Well, in today's day and age, with DCC and decoder modules, if you don't know a locomotive's going bad or that it's drawing a whole bunch of power, you're likely to burn up the motor and or the decoder before you know it. Okay, so having an alpha meter in line allows you to visualize that. Now, these alpha meters will work for DC, they'll work for AC, and they'll work for DCC, okay, which is a square wave pattern. And what's nice is the LED readouts, depending on how you have things wired, will be different colors for, as an example. If the lettering's in blue, that's DCC. Okay. If it's in green, that means it's straight DC voltage. All right. And if it's in red, that means it's AC power. So there are model railways that have a switch. You can put a double pole, double throw switch in, and switch your power from DCC to DC or vice versa, and you'll know it based upon the color of the readout. That's going beyond what I want to do. So today, I'm going to install this. Now, one thing they recommend is that you put this in line as close as possible to the track. Okay? And they say that's very important. And it is depending on your train of thought. If you're trying to figure out how much power a locomotive's drawing, having it close to where the locomotive, closer to the locomotive, is better than closer to the power pack. And if you're more interested in how much power output is drawing on the power pack, then closer to the power pack. In the grand scope of things, unless you have a huge layout, it's not going to matter. Okay, especially if you use oversized wiring on your layout to reduce voltage drop over long distances. This room here is 9 by 22, and it's a folded dog bone. So the bus line, the furthest the bus line is away from the power pack's 15 feet. Okay, the furthest point on that bus line. But the furthest point, and I say that because from the power supply it goes and then tees. And depending on which direction you go, the longest is 15 feet. Okay, and I use oversized wire. I use 14 gauge wire. There's literally not going to be a measurable amount of voltage drop over 14 feet. Okay, on 14 gauge wire. If I was running 22 gauge wire, different story. All right, but the bus lines are all 14 gauge wire with 18 gauge feeders, so there's no real problem. So this, I'll swing the camera or switch cameras, and I'll show you where I'm going to mount it in relation to where the power supply is, etc., etc., etc. Stay tuned. All right, this is the panel that we're going to use for the alpha meter. Mount right here. Okay. And I'll drill, there's a template in the packaging, and basically from my Digitech power supply, 2 wires into this, 2 wires out of this to my PM42, Power Management 42 circuit breaker system. Alright, so that'll measure all power on all tracks at a given point in time. Remember, none of my lighting is on my DCC power buses. That's all separate power bus. The only thing is the track and the switch machines. Okay? So I'll be able to gauge power fairly well. Now, where is all this lead to? Well, the power supply is right under here on a shelf, literally a foot away from where I'm going to mount it. Where's the PM42? Right next to the power supply. So it's a foot out, a foot back to the PM42. And then from the PM42 it branches out into the 4 bus lines. And those connections are 1 foot to where the T is. To where the T is that goes in both directions. Okay? So it's all it's fairly close to as close as I can get it to be effective. So we'll unpack this. You see that there is a nice little template right here. Tape on here. I'll make the marks. Cut out the panel. Put some pilot holes in, and this will be ready to mount up. Okay. And as far as the wiring go, I'll just pre-wire a couple sets of leads, and it should be easy. It comes. They supply screws. They supply plugs, so I can make my leads. And then these plugs will plug right into the alpha meter. All right. So stay tuned. Okay. So I say okay a lot, don't I? All right. I've got the 8 holes marked. All right. There's 4 for mounting, and then 4 corner holes for where the cutouts got to be. Now the cutout holes, the 4 cutout holes I did very small. I'll come back with a larger drill bit and drill those out so that I can get a jigsaw in there to cut out the hole. All right, so stay tuned. All right, time to clean up a bit and then make up our leads. Once we have our leads made up and plugged in, then we will mount the board and then hook up each of the ends, input and the output. One to the Digitrax power, logo it, and the other to the PM42. So, stay tuned. All right, so we got it mounted. We have it wired up. Let's see if we get it working or not. All right, Alexa, trains on.
Sorry, something went wrong.
Well, that's not a good thing. Alexa, trains off.
Okay.
Alexa, trains on.
Okay.
Track power on, no wonder. All right, I pulled a Heath. It's Heath's fault. Let's try turning the power on to the tracks, to the rails. Here we go. Hi, Joe. I think we've got it. It's in blue, and as I mentioned early on, when it's blue, it is accurate DCC power. All right. So I am showing 14.63 volts coming out of power supply, feeding the tracks, and I'm showing 0.98 amps. Now that is, let me double check, I should not have any locomotives powered up. Should have all feeders, sidings turned off. Here's one that's not. There's no locomotive on it. No locomotive on it. No loco, no loco, no loco, no loco. Okay. So, what that means is my switch machines in total are pulling about 0.98 amps. Okay? So let's see what happens when I fire up a single locomotive. Let's do the Baltimore and Ohio E9 that I put a decoder in yesterday. So, idling at E9 took it from 0.98 to 1.02 amps. So, what's that? 0.05 amps for the locomotive? I'd say that's pretty efficient. So, I'm real happy. 14.5 amps is good. Volts is good to the track. And idle, nothing powered up other than the switch motors, the Smales. They're DCC switch motors, and they are constant power thrown, so you have constant pressure on the switch to maintain them, to maintain position, which is what I want. That draws just less than an amp. And let's take the Baltimore and Ohio for a spin, and we'll see what it draws. Okay, let's. Coming out of the roundhouse, just idling basically out. All right. Keep in mind these decoders are only rated at like 1 amp. I know the Digitracks are like 1.5 peak, so if they derail, etc., it's not going to blow up a decoder, or it's not as likely to blow up a decoder. Let's back her out. So it helps to put it in reverse to back it out. Okay, I'm gonna put it full throttle. Let's watch that amp meter, shall we? Full throttle. We initially drew a half an amp. It's going uphill with the load. Comes back down, levels out. Down to about 0.3 of an amp on level of the ground. And again, that's a full throttle. And then back to idle. Slide this around where hopefully you can get a better view of what it's reading. How's that? Okay, so that's at idle, 1.02. And if you recall, 0.98 of that is for the switch motors. So let's take her full throttle in reverse, see what she does. Voltage stays pretty constant. This is going to be going downhill most of the way. It's not going to go up very much. Full load, it goes up less than half an amp. And there she is right there. Yay! Alright, back to idle. So at idling, it's only taking like 0.02. If you recall, I'm going to put her back in the shed, and the isolator will drop back down to just the switch motors. Alright? part, I'll be running at about this speed. Quarter of an amp. Alright. Put it back in a barn, isolator, and see what the idle is. Turn the light off, see what it does. So about 0.02 for the light, and idle is probably another 0.02. Okay, isolate the engine, drops down to 0.97, start at 0.98, so just draw from the snails. Alright, so there you have it. A simple installation of the DCC Concepts alpha meter, and a brief overview of what the benefits are for it. Switch cameras. Okay, so there you have it. Simple, easy to do installation of a DCC Concepts alpha meter, and I'm really pleased. It went exactly according to what the instructions were. Just simple template, drill holes, cut out a notch, take two wires that are going to the track, undo them from the track, put them in the alpha meter, out of the alpha meter, back to the track. Simple. Okay. So simple, I can do it. All right. So you can be like Steve, or not. Again, thanks for joining me here at the Retirement Railroad Matinee Modeling Tip of the Day. I'm Steve, and y'all have a great day. Bye now.